Welcome back to Hardware Unboxed. Today I have a build video. I've built a few new PCs this year, but I don't believe I've built a single Mini-ITX rig, which I have to say is a real surprise as they're usually my favourite to put together. Mini-ITX builds usually throw up a few challenges, which makes the process a little more enjoyable, at least it does in my opinion. They also look great, and cramming a high-end desktop build into a compact case, well, that just never gets old. The purpose of today's build is to upgrade my wife's computer. She's a graphic designer slash photographer, and she does a lot of work with magazine layouts. So this means she spends a lot of time in Adobe InDesign, and of course she uses Photoshop as well. I have to admit I have kind of neglected to keep her computer up to date over the years, though having said that, she's been pretty happy with the setup that she's had up until now. It's done pretty much everything she's needed to do. It's just started to run into some problems recently, and every time I've offered previously to upgrade it, she said it's fine, don't bother. Now though, it is time to bother. So we've pulled the old system apart, which is in the Thermaltake Suppressor F1. As you can see, it's pretty well been gutted now. And that did have a Core i5 4670K CPU. I don't know if it was overclocked, I honestly can't recall. And that was on the ASRock Z87 E-ITX motherboard, so that's obviously still in there. Had 16 gigabytes of memory, DDR3 memory, and it had a fairly underwhelming Radeon R7 250 graphics card, but that's all she needed for the work that she was doing. In the last month or so though, the old Haswell quad-core rig has started running out of memory, and this has caused issues with InDesign. There's really no cost-effective option to solve the RAM capacity issue, because as you just saw, the Mini-ITX board only has 2 slots, so we'd have to ditch the 16 we've got and try and find a 32 gigabyte kit. Definitely not worth the hassle. So about a month ago, I decided to quickly hack together a Ryzen 7 test build with 32 gigabytes of DDR4 memory to see how that played with the Adobe software she was using. The upgrade was significant and very noticeable. InDesign layouts would work at the full resolution, and there was no stuttering or slowdowns when scrolling through the pages. Photoshop was also noticeably better. Working with high resolution raw images was smooth, and the Ryzen 7 system never complained about the workload. So with that successful test run complete, it was time to build the new workhorse. It was strongly suggested to me that I stick with a Mini-ITX system. She wants to keep it on her desk, but doesn't want it to take up too much room. She was very happy with the Suppressor F1 that she had. Height wasn't an issue here. The only requirement was a small footprint, so this afforded me the opportunity to finally create a build in the Phanteks Evolve Shift. For this one, I'm yet again sticking with ASRock, this time using their new Fatality AB350 Gaming ITX AC, my favourite Mini-ITX AM4 motherboard. Then coming to the rescue and solving the memory issue is Team Group with their Team T-Force Vulcan 32GB DDR4 2400 memory kit. Ideally, I would have liked a higher clocked memory kit for this build, but capacity was the main concern. I really needed 2 16GB sticks. It is possible with some tuning that you can get more out of this memory, and I played around in the BIOS and was able to get this memory running at DDR4 3000 speeds simply by loading the XMP profile and then upping the frequency while leaving the timings the same. So you are overclocking the memory, your mileage may vary, but this memory did seem to overclock very well. Moving on, powering the build, I have the Silverstone SX650G, a compact SFX power supply with a big 650 watt output. It also has an 80 plus gold certification and a fully modular design, so it's perfect for this Mini-ITX build. I was pretty keen to get started with the build, so much so that I rushed the planning stage, and well, that turned out to be a bit of a mistake for a few reasons. Not a disaster, but a few things did go wrong. My first error was requesting the Phanteks PHTC12LS for the build. It's a great little cooler, but I ran into not one, but 2 problems right off the bat. The second of which I will get to in a moment, but that one proved fatal for the cooler's inclusion. The first issue that I ran into was actually the lack of AM4 support, so that should have been an obvious one, and the cooler hasn't been updated to offer support either. I told you my complete lack of planning backfired on this one. Anyway, I did work around this issue with the help of 2 small washers, which I used to jerry-rig the cooler to the AM4 socket, and this worked surprisingly well. I was able to create even pressure for a perfectly flush connection with the CPU's heat spreader. Thermals were good. That was until I decided to install the glass panel on the side of the case for my final testing. And I realized that the 120mm fan had about 4mm of breathing room between it and the glass. So that kind of limited how efficient the fan was. and thermals did rise a bit. It was still manageable, but you wouldn't have been able to overclock the way it was set up, and it just didn't really make that much sense. It looked cool, but didn't make that much sense. Again, had I planned the build, this issue probably would have been spotted ahead of time. Anyway, I've never worked with the Phanteks Evolve shift before, so this entire build was a bit of a learning process, or rather, learn as you go process, which probably isn't the best way to do it, but it's the way I did it this time. I knew the case was designed to take advantage of all-in-one liquid coolers, and I thought, well, I'll chuck in Vega 64 and really see what it can do, and then use this air cooler, but that's obviously backfired and didn't work out. You can install a pair of 120mm radiators. It's possible to put one in the bottom, like I have here, and then one in the front, but it's very tight. You have to sort of orientate them in a specific way, and it's very crammed, and I didn't like it, so I decided to ditch that. I also was a bit concerned about thermals, and since I'm not going with a Vega 64 liquid card in this for my wife, I decided to just pull that out. I'm not going with the Titan X either, but that's sort of beside the point, kind of. Anyway, that's how it's configured for now. Truth be told, though, the system really doesn't require that much 3D rendering power, so the Pascal Titan X is obviously overkill for this build, and I will go for something, maybe like a GTX 1060 will find its way into the final build. Now with the 120mm rad spot freed up, I grabbed the Cooler Master Liquid 120 and relocated the jazzy looking Corsair LL120 fan. And I've got that rotating between orange and red, and that looks pretty cool. All up, I would have to say, if I'm being honest, I built this system probably about 4 times, or at least the majority of it, shuffling things around. Cable management took a bit of messing about, and of course I changed quite a few components from the original configuration. So yeah, quite a lot of work went into building it, but had a lot of fun doing it. And yeah, although it was probably the worst planned build I've done this year, I did have a lot of fun. It was probably one of my most fun builds actually of the year. I enjoyed sort of tuning it and tweaking it and getting it a little bit better each time I did it, and working out the best way to build in the shift. It was just a lot of fun. I know, I probably need to get out more. Anyway, now that it's complete, I decided to run a few temperature tests, and I've left the front 140mm fan. That's exhausting air out the front, and I can feel it blowing all the air out. So I've left that exhausting air. Then we've got the 120mm fan in the bottom, and that's pushing air out through the radiator. So basically both fans are sucking air out of the case. They're both exhaust fans, and they're the only fans that we have in the system. And then they'll be sucking, the air that they're pushing out will be drawn in through the ventilation here. So hopefully that works pretty well. I have to say I'm a little concerned. It does have it appears to have very limited airflow. Only those 2 fans. Of course, each side panel is non-ventilated because they are tempered glass panels. And doesn't appear that there would be a whole lot of airflow over the motherboard VRM area. Not too worried about the graphics card on the other side. That should pretty well take care of itself. But anyway, we'll jump into the temperature results and see what's what. First up, I ran the IDA stress test, stressing both the CPU and FPU, and here are the results. Out of the box, so that is to say the stock operating clock speeds, the Ryzen 7 1700X maxed out at just 59 degrees, while the motherboard's VRM heatsink reached 62 degrees. I used a thermal probe to measure the underside of the heatsink and reported the maximum temperature after the hour-long stress test. And for anyone wondering, for all of these tests, I did have an ambient room temperature of 21 degrees. Overclocking the 1700X to 3.9 GHz, which is the maximum frequency I've been able to achieve with this CPU on any motherboard, temperatures did soar to a very warm 82 degrees. Still, this is a very safe operating temperature, so no problems there. The VRM heatsink peaked at 71 degrees, which is also very safe. For the most part, you're not going to be stressing the CPU as hard as the IDA64 stress test, so what can you expect when gaming? For this test, I used Battlefield 1 and recorded the temperature over an hour of gameplay. Although the CPU isn't working as hard, the Titan X is now pumping out heat. A lot of heat, though most of it is forced out the top of the Phanteks case, thankfully. A few things worth noting: the Titan X basically targets 84 degrees under load. The fans spin up at whatever speed is required to maintain a thermal limit of 84 degrees, and when the fans are maxed out, you will start to see the GPU throttle in order to maintain an 84 degree temperature. So even on an open testbed, the card will quickly hit 84 degrees and then maintain that temperature under load. I should also note the Titan wasn't overclocked in either of these tests, just the Ryzen 7 CPU was overclocked. And finally, the Titan X was surprisingly quiet as the fan speed maxed out at just 2400 RPM. So as you can see when gaming, despite the Titan X now pumping out quite a lot of heat, the CPU and motherboard actually ran cooler, as they're not being stressed as heavily as they were in the previous test. In summary, the operating temperatures when gaming are very impressive, and the system was also very quiet. Only the Titan X could be heard when gaming, and even then, it wasn't particularly loud. Overall, I'm very impressed with how this build's turned out, and it's just occurred to me that this is actually the first ever, and I mean first ever, AMD-powered Mini-ITX system that I've personally built. I don't think I ever slapped together an FM2 Mini-ITX system, and I'm pretty certain I never built an AM1 rig, so this is probably, I'm fairly certain, my first ever AMD Mini-ITX build that I've had the pleasure of putting together. The only item I would change in this build if I was buying it or making it for myself, and I'm assuming gaming's on the table here, maybe a home theater, PC gaming rig or something along those lines, I would go for probably a GeForce GTX 1080. That would be a really nice fit, really good for 1440p gaming. It would complement this really well. So with the Ryzen 7 1700X, 32GB of DDR4 memory, a Samsung 960 Pro 512GB SSD, and the GTX 1080, plus all the other stuff such as the Silverstone PSU, the ASRock Mini-ITX motherboard, and of course the Fantex Shift case, you're looking at about $2,000 US all up. Considering what you get for that money, this, in my opinion, is an exceptional rig. 1440p or 144Hz gaming won't be an issue, nor will serious productivity work. It's really a jack of all trades, and it takes up just 170 by 274mm of desk space. It's also quiet and allows for very reasonable operating temperatures, especially for a case that's lathered in tempered glass. I love it, and I hope you guys enjoyed the build video. That's going to do it for this one. I'm your host, Steve. Catch you again next time.